Introduction.
Can anybody tell me what happens when we keep a bowl full of petrol open in a room? The petrol will evaporate, teacher. That is correct. You see that the energy generated by petrol is evaporated in the environment, but in a form that is not usable. However, if we use the same petrol in our bike, the petrol is converted into an energy source that is usable.
Children, in this lesson, we will learn about the conventional sources of energy and the non-conventional sources of energy and its impact on the environment. Objectives. At the end of this lesson, you will be able to identify conventional sources of energy, identify the non-conventional sources of energy, describe the environmental consequences, explain the duration of the energy sources. A good energy source. In your day-to-day life, you need a lot of energy throughout the day. All physical activities that you perform require energy. Also, this energy comes from a source that would give you the required energy to perform any activity. You need to keep in mind that any good energy source must assist you in performing a large volume of work, be easily available, be easy to store and move from one location to another, be affordable. Conventional sources of energy, fossil fuels. Fossil fuels are generated by natural processes. They include a high percentage of carbon. These are non-renewable sources of energy as they take millions of years to form. The reserves of these fuels are reducing at an alarming rate. The types of fossil fuels are coal, petroleum, natural gas, heavy crude oil. Conventional sources of energy, thermal power plants. A thermal power plant is an industry where energy is generated by steam. Here, water is heated and then it is turned into steam. This in turn spins a steam turbine, driving an electrical generator. After it passes through the turbine, the steam is condensed in a condenser and recycled to where it was heated. Conventional sources of energy, hydropower plants. Hydropower plants generate electricity from the energy of falling water. Hydropower is a renewable source of energy. The advantages of hydroelectricity are: the cost of hydroelectricity is low. Hydroelectric power supply is more suitable for industrial applications. No carbon oxide is produced as no fossil fuels are burnt. Did you know? Burning fossil fuels generates around 21.3 billion tons, 21.3 gigatons of carbon dioxide, CO2, per year. Natural processes can only absorb about half of that amount. As you can see, there is a net increase of 10.65 billion tons of atmospheric carbon dioxide per year. Biomass. Biomass is a renewable energy source and is generated from biological material that is derived from living or recently living organisms. As an energy source, it is either used directly or converted into other energy products such as biofuel. For example, forest residues such as dead trees, branches and tree stumps, yard clippings, wood chips and even municipal solid waste. Biomass also includes plant or animal matter that can be converted into fibers or other industrial chemicals. Wind energy. Wind power is the conversion of wind energy into a useful form of energy, using wind turbines to make electricity, windmills for mechanical power, wind pumps for water pumping or drainage, or sails to propel ships. A large wind farm consists of several hundred individual wind turbines that are connected to the electric power transmission network. Offshore wind farms harness more frequent and powerful winds than are available to land-based installations. They have less visual impact on the landscape, but construction costs are considerably higher. Small onshore wind facilities provide electricity to isolated locations, and utility companies increasingly buy back surplus electricity produced by small domestic wind turbines. Did you know? All large wind turbines have the same design, a horizontal axis wind turbine with an upwind rotor with 3 blades, attached to a nacelle on top of a tall tubular tower. In a wind farm, individual turbines are interconnected with a medium voltage power collection system and communications network. At a substation, this medium voltage electric current is increased in voltage with a transformer for connecting to the high voltage electric power transmission system. Alternate energy sources. As we progressed, our day-to-day life activities also changed. We now get most of our work done by machines. Due to this, we need to look for alternate sources of energy, as our natural resources are not sufficient to provide for the energy in our machines. Examples include solar energy, energy from the sea, geothermal energy, nuclear energy. Solar energy. Solar energy is derived from the radiant light and heat of the sun. It has been used by humans since ancient times for a range of technologies. Solar energy is used for architecture and urban buildings. Solar energy is also used for heating water in our day-to-day life, where the solar hot water systems use sunlight to heat water. In low geographical latitudes, the domestic hot water usage is provided for with temperatures up to 60 degrees Celsius by solar heating systems. The most common types of solar water heaters are evacuated tube collectors and glazed flat plate collectors, generally used for domestic hot water, and unglazed plastic collectors used mainly to heat swimming pools. Energy from the sea. Tidal energy. Tidal energy is a form of hydropower that converts the energy of tides into electricity. This is a renewable source of energy. Tidal energy is extracted from the oceanic tides. Tidal forces are periodic variations in gravitational attraction exerted by the moon. This force creates motions or currents in the oceans. Due to the strong attraction to the oceans, the water level rises. This leads to the water from the middle of the ocean to move towards the shorelines, creating a tide. This is an unfailing occurrence due to the consistent pattern of the moon's orbit around the Earth. The energy generated by the tide is saved by constructing a dam on a narrow opening to the sea. A turbine is then fixed at the opening of the dam that converts this tidal energy to electricity. Energy from the sea. Wave energy. Wave energy is the generation of energy by oceanic waves. We can capture this energy to do useful work, for example, electricity generation, water desalination, or the pumping of water into reservoirs. Waves are generated by wind passing over the surface of the ocean. As long as the waves move slower than the wind speed above the waves, there is an energy transfer from the wind to the waves. Both air pressure differences between the upwind and the wave crest, as well as friction on the water surface by the wind, makes the water undergo shear stress that causes the growth of the waves and in turn helps in generating wave energy. Energy from the sea, ocean thermal energy. Ocean thermal energy uses the temperature difference between cooler deep surface and warmer shallow surface ocean waters to run a heat engine and produce useful form of energy, mainly electricity. The heat engine gives greater efficiency and power when it is run with a large temperature difference. In the oceans, the temperature difference between surface and deep water is greater in the tropical areas, and other areas it is a modest 20 to 25 degrees Celsius. After the surface water is sufficiently warm, it is used to boil volatile liquid ammonia. The vapors of ammonia are then used to run a turbine. The cold water is then pumped from the depths of the ocean and is used to condense the ammonia vapor back to the liquid. Did you know? The Earth receives 174 petawatts of solar radiation at the upper atmosphere. Approximately 30% is reflected back to space, while the remaining 70% is absorbed by clouds, oceans, and land masses. Geothermal energy. Geothermal energy is thermal energy generated and stored in the earth. Molten rocks are formed in the deeper hot regions of Earth's crust. Heat conducts from the Earth's core to the surrounding cooler rock. The high temperature and pressure causes some rock to melt. This heats the rock and water in the crust, sometimes up to 370 degrees Celsius. Geothermal energy is used for hot springs and space heating. Nuclear energy. Nuclear energy uses sustained nuclear fission to generate heat and electricity. It is a sustainable energy source that reduces carbon emissions. Nuclear energy is generated by a process called nuclear fission. In this process, the nucleus of heavy uranium, plutonium, or thorium is bombarded with low-energy neutrons. This atom is then split into lighter nuclei. A tremendous amount of energy is released. For example, the fission of an atom of uranium produces 10 million times the energy produced by the combustion of an atom of carbon from coal. Environmental consequences. Using any source of energy affects the environment around us. Therefore, before exploiting any energy source, ensure that it does not disturb the environmental balance and is harnessed judicially. Renewable sources of energy last for as long as they keep generating, whereas non-renewable energy runs out. We have to be judicious in our selection of energy, the purpose of the energy being used, and the actual usage of the energy. Summary. Let us summarize what we have learnt. Using a good source of energy is advantageous. Conventional sources of energy include fossil fuels, thermal power plants, and hydropower plants. The conventional sources of energy improved with the use of biomass and wind energy. Solar energy, energy from the sea, geothermal energy, and nuclear energy are all alternate sources of energy. Renewable sources of energy last for as long as they keep generating, whereas non-renewable energy runs out. We have to be judicious in our selection of energy, the purpose of the energy being used, and the actual usage of the energy, so as to avoid affecting the environment around us.